f of x is equal to 4x square plus 64x plus 262. The function g is defined by g of x is equal to f of x plus 5. For what value of x does g of x reach its minimum? To find the value of x where the function g of x reaches its minimum, we need to analyze the vertex of the function g of x, which is obtained by shifting the vertex of f of x horizontally by 5 units to the left. The function f of x is given by 4x square plus 64x plus 262. So here we have a value to be 4 and b value to be 64 and c value to be 262. Therefore, the vertex of the function f of x can be found by x equal to negative b by 2a, which is nothing but negative 64 divided by 2 times 4 is 8. So we have 8, which is nothing but negative 8. So x is equal to negative 8 is my vertex for f of x. Now we need to find the vertex of g of x by shifting the vertex of f of x by 5 units to the left. So we have the vertex of g of x, which is nothing but negative 8, and since we shift the 5 units to the left, we have negative 5, which is equal to negative 13. So this is where my g of x reaches its minimum. Therefore, option A is my correct answer. Let's move on to our next question. A quadratic function models a projectile height in meters above the ground in terms of time in seconds after it was launched. The model estimates that the projectile was launched from an initial height of 7 meters above the ground and reached a maximum height of 51.1 meters above the ground 3 seconds after the launch. How many seconds after the launch does the model estimate that the projectile will return to a height of 7 meters? So here we need to find a quadratic function with respect to height and time and use that to find when the projectile will return back to its initial height. So let's draw a graph to understand the question better. So in the y-axis, I'll be taking my height in meters, and in the x-axis, I'll be taking my time in seconds. So the projectile was launched from an initial height of 7 meters, and after 3 seconds, it reaches a maximum height of 51.1 meters. So the graph is going to look something like this. So here my vertex is nothing but 3, 51.1. Now after some time, the projectile reaches the initial height here, and I need to find the corresponding x value. So I need to find the x value for the point x, 7. So let's consider our quadratic equation with the vertex form, which is given by f of x is equal to a times x minus h the whole square plus k, where the vertex is given by h, k. So let's write the equation with respect to our question above. So I'm going to take my f of x to be h of t, which is equal to a times t minus our vertex is nothing but 3, 51.1. So we have t minus 3 the whole square plus 51.1. So we know that at t equal to 0, our initial height is nothing but 7 meters. So using this, we'll have to solve for a. Therefore, we have h of 0, which is equal to a times 0 minus 3 the whole square plus 51.1. So we have 7, which is equal to 9a plus 51.1. So subtracting 51.1 on both sides, we have 7 minus 51.1, which is equal to 9a. And finally, we have a to be equal to negative 44.1 divided by 9. So this is my a value. So we need to find the time when the projectile will return back to its initial height after t seconds. That is, for some t, I need my h of t to be equal to 7. And now that we know our a value, let's plug in the values of h of t and a and solve for t. So we have h of t is equal to negative 44.1 by 9 t minus 3 the whole square plus 51.1. So we have 7 which is equal to negative 44.1 by 9 t minus 3 the whole square plus 51.1. I'm just gonna clear some space over here. So we have 7 which is equal to negative 44.1 divided by 9 t minus 3 the whole square plus 51.1. So subtracting 51.1 on both sides, we get 7 minus 51.1 which is equal to negative 44.1 divided by 9 times t minus 3 the whole square. So we have negative 44.1 which is equal to negative 44.1 divided by 9 t minus 3 the whole square. So I'm going to divide both sides by negative 44.1 divided by 9. So I'm going to get 9 which is equal to t minus 3 the whole square. Now taking square root on both sides, I'm going to get plus or minus 3 which is equal to t minus 3. So this has two possibilities, that is one with a negative, that is minus 3 which is equal to t minus 3, and another possibility with the positive, we have 3 which is equal to t minus 3. So which first case is nothing but t which is equal to plus 3 minus 3 which is equal to 0, and t which is equal to 3 plus 3 which is equal to 6. So t equal to 0 represents our initial value, that is initial height, and when it reaches back to its initial height after some seconds is nothing but at t equal to 6. So let's see our options here. Option B is my correct answer. Let's look at our next question. So it's given that f of x is equal to a modulus of 59 minus 2x. The function f is defined by the given equation. For which of the following value of k does f of k is equal to 3k? So let's write our given equation. We have f of x to be equal to modulus of 59 minus 2x. So we need to find the value of k when f of k is equal to 3k. So all we need to do is substitute our value of x to be equal to k in the equation above and equate it to 3k and solve for k. So let's substitute our x value to be k. We have f of k is equal to modulus of 59 minus 2k equal to 3k. Here we need to consider two cases, that is when 59 minus 2k is greater than or equal to 0, and another case where 59 minus 2k is less than 0. Let's consider our first case. We have 59 minus 2k equal to 3k. Now simplifying this, we are going to get 59 is equal to 5k, where k is equal to 59 divided by 5. So this is my k value. Now let's move on to our next case, which is nothing but negative of 59 minus 2k is equal to 3k. Now multiplying the negative sign, we have negative 59 plus 2k is equal to 3k. Therefore, k is equal to negative 59. Now when you take the modulus value, it's going to give us a positive value. Therefore, I'll consider my positive k here. Therefore, option A is my correct answer. Moving on to our final question. For the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k as the coefficient or the base? So let's write a general equation for an exponential function, which is given by f of x is equal to a times b to the power x. Now here a is my coefficient and b is my base. So given that f of 1 is equal to k is nothing but at x is equal to 1, I am getting a value k such that it is either present in the coefficient or in the base. So all I'm going to do is substitute my x value to be equal to 1 in all these four options and find out which value has value which is present in the coefficient or in the base. So let's consider our first option, that is option A is given by f of x is equal to 50 times 2 to the power x plus 1. So when I substitute x to be equal to 1, I'm going to get 50 times 2 to the power 2, which is equal to 50 times 4, which is equal to 200. So 200 is neither present in the coefficient or in the base. Therefore, option A is wrong. So now let's consider our option B. So option B is given by f of x is equal to 80 times 2 to the power x. So substituting x value to be equal to 1, we have 80 times 2, which is equal to 160, which is not present in either the coefficient or in the base. Therefore, option B is also wrong. Next, we'll consider option C, which is given by f of x is equal to 128 times 2 to the power x minus 1. So substituting x to be 1, we have 128 times 2 to the power 0. 2 to the power 0 is 1, so we have 128. So 128 is present in the coefficient term. Therefore, my answer is option C. But let's try option D as well to just confirm the right answer. So finally, we have option D, which is given by f of x is equal to 205 times 2 to the power x minus 2. So which is given by 205 times 2 to the power negative 1, which is nothing but 205 divided by 2. Obviously, this value what I'm going to get if I in terms of decimal is not going to be present in the coefficient or in the base. Therefore, option D is also wrong. Thank you for watching our video. Please like, share and subscribe.